Welcome back. So today we're going to use the Ranger PM7000's PMScreen application to configure and display information. So at the moment I'm going to share my desktop and we will set up our Bluetooth connection to the instrument. I'm going to add a Bluetooth device. It should find my unit. There it is right there. We're going to click on pair. We have an Android application as well, and you will still need to pair it using the Bluetooth for it to operate appropriately. So now our unit is connected. I'm going to connect up and start Pronto for Windows. And I'm going to edit my logger address. At this point, my baud rate for all Bluetooth units on the Ranger product line are 115,200. If I was using the USB connection to the PM7000, it would be 921 kilobaud. I'm going to click on the search button and my Bluetooth serial port, and there's my serial number, is COM21. If I was using the USB connection, it would show an FTDI port there. So we'll click on that, click on OK, and we're going to connect with PMScreens. So the first thing that you'll notice, we're going to go back to the original menu here, is it gives you the serial number, the nomenclature of the unit, the time, the date, that it's in record mode and it's charging right now. You have a main menu, you have a help menu here. This basically gives you an indication of contents where if you wanted to know what different phrases might mean, like what low signal means, you can click on it and it'll give you some background information. We'll just exit out of that. You also have a connection wizard here that tells you that it's set up for a 3-phase 4-wire Y, but it's showing low signal. So let's see what's wrong there. If I click on it, it shows how things are supposed to be connected. These are your AC highs, these are your AC lows or your neutrals, and you notice they're all connected up, and these are your current inputs. We click on details. You'll see that my A phase voltage is good, but my B and C phase is not. It's low and I have no currents. Well, it's to be expected. I'm just basically plugged into the wall, right into A phase. One word of note is if I did have currents connected and if I showed phase reversed here, I can hit this equal sign and flip the signal in software without actually going in and flipping the Wagowski coil or the iron core C2. So I'm going to click on finish. Now the first thing where you need to do is set up the unit, but it's in record mode. So we're going to stop the recording. And we're going to go into configure. There are a bunch of preset configurations that are from the factory. They're listed in the configuration guide. They're all based on 7-day recordings, but we're going to create our own. So we're going to go to hookup here, and we're going to select whatever type of circuit we're going to connect to. And you'll see 3-phase 4-wire Ys, deltas, 3-phase 3-wire Ys are grounded, 2.5 element, split phase, single phase, uncommitted. Basically, we allow you to connect it up to pretty much any type of service you want, assuming that you're going to meet the voltage and current requirements of the unit. I'm just going to select a 3-phase 4-wire Y, click on accept, and let's set up a record mode and time. I only want to do a 1 day, but I'm I want to get information every day. We actually have an Android application, and what I plan on doing is putting an Android phone out there, and the phone will pull the instrument every day and actually every hour. And once the recording is done, it can email me the file. So every morning I can come in and see what happened the day before. You can set this up however you like. It's very, as you can see, right now I have it set for 17 days, but I'm going to change this and clear this and set it up for a 1-day session. And under memory use, the maximum you want to do for first in, first out, which is what I want to do, because after the recording is completed, I want it to start a new recording. So I get the information, but the unit is still out there recording. I'm setting it to 40 meg. That's what's recommended. And I have my detailed recording channels, which are my 32 parameters with a single cycle adaptive store, set to 33. My general parameters, those are the 500 parameters that are background information that you may need in the future. And my waveform capture is set to 33%. That's all my waveforms for all my 8 inputs. And you can change this just by clicking on the graph if you want. Change that back. Accept. You have two FIFO. Again, first in, first out. That's a recycling mode. I want it on for this particular application. If you were leaving it out there for, you wanted to do, let's say, a 2-week time period, and that's all you were going to do, you can leave it out there for 2 weeks and turn the recycling off and increase the amount of memory to use all the memory, and after 2 weeks, it'll be there. We have 2 storage modes. Point store is the way everybody else records. So right now it's set, if I did a recording in point store, the interval is 1 minute. It'll give you a 1 cycle max, a 1 cycle min, and an average of all those cycles over that minute. But in the adaptive store, you don't have to set an interval, and it gives you the best resolution on changes that occur over that record period. So if I had it set for a week time period, I could actually get detailed down to single cycle, even over 1 or 2 weeks. General parameters, this is the background information. Right now I can go for 19 days, but let's tighten this up here. This is all the background information. And you notice if I set it to 1 second for the general parameters, it turns red and it says, hey, if you have your general parameters set for 1 second based on the memory, you can only go for 230 minutes. So I'm going to open that up a little bit. Let's go to 10 seconds. That gives me 38 hours. That's good. Click accept. Flicker, you probably won't need to change this. The specification is 10 minutes and 2 hours. 10 minutes for short term, 2 hours for long term. So we'll just accept that. Detail recording channels. So this is where you set up the information that you really want to see. So I'm going to click on clear all. And based on the hookup, I can click on this suggest new functions. And it's going to ask me, since you have A phase RMS selected, a voltage, do you want to do B phase? And I do. And you'll notice this number increments here as well. I'm going to also choose C phase and neutral to earth. I can do phase to phase, and I'm going to select those. I'm going to select my 4 currents. DHD, all my harmonics are actually getting recorded in my general parameters, so I typically don't waste detailed recording channels on those, but I'm going to select some other parameters here. One thing I'm interested in is flicker sensation, which is an instantaneous flicker, and we're going to select that for A phase, and then it's going to ask me, do you want B phase? And we'll select that, C phase as well. And since it's a 3-phase recording, I'm going to click on my function group called AC 3-phase and select my 3-phase 4-wire real power. And we'll click on reactive power as well, parent power, power factor, voltage imbalance, and that's probably it for that. If I click on other again, you'll notice that we have a bunch of these function groups, and each function group has a bunch of functions that you can choose to record. So a couple of the other ones that are of note under harmonics, you'll see plus or minus of harmonic. So this will give you harmonic width direction over time. So it'll tell you if it's coming from the source or from the load. Under inner harmonics, this particular unit has that option, and that particular option, you can record in harmonic groups, subgroups. You can actually get out to the 100 harmonic if you want, if you have that option installed. So right now we have 19 channels set. We're going to go back to return to list and accept, and we're going to set up our input signals. So if I'm on the secondary of a potential transformer and I want to read the primary voltage, I would click on that and put the potential transformer ratio in there, but I'm not. And if I'm on the monitoring on the secondary of pad mount CT, I could put the ratio in here, but I'm going to monitor it direct this time, so I'm going to unclick that. And I'm going to use my Rogowski coils as opposed to the ion cores, the closed-pin CTs. But I'm not quite sure of the maximum current that I'm going to record. So because it's a 400 amp service, but I might get some spikes that might go higher. And I don't want my current to clip. So what I'm going to select is my 6,000 amp range, because if I select 400.0 amps, and let's say I get a current surge spike that might go up to 600 amps, I'm going to clip my signal. So I'm going to the next higher one there. So I'm going to use those flexible Rogowski coils for this hookup. I'm going to click accept, and then I'm going to click on waveform capture. And everybody else's unit, you have to set in bandwidths or thresholds, and the problem with that is if you guess too tight, you'll end up using up your waveform buffer very quickly. If you have your bandwidth too broad, then you could record for 2 weeks and still not have your waveform buffer full. So I'm going to click undo on this, and I'm going to use our general greatest disturbances. And by using that, you'll notice threshold is grayed out. And let's see, these are the different triggers I can use: transients, rings, notches, sags, surges, THD voltage, THD current. For this application, I want to capture THD voltage as well. And you can manually allocate these, or you can set them automatically. I'm just going to set them automatically. And how the greatest disturbances work is, as you start a recording, it'll sort the waveforms that are coming in into these 3 different bins. So I have a bin for transient, sags, and a third one for THD voltage. So the first one might be a transient, the second one might be a transient, the third one might be a THD waveform capture, fourth one might be a fall, and it keeps on going until one of these bins is full. And then once I have 48 waveform sets of transients that are in there, it'll look at the incoming waveform and determine if it's a transient, and then it'll compare it to those 48 waveform sets and determine, gee, is it a greater disturbance than the ones I have in store? If it is, it will store it, and it'll throw out the least significant. I'm going to click accept. This is where you can set up your pre and post buffers. Right now I have it set for 1 pre and 3 post. I'm going to extend this to 4 post by clicking on the trace. And you'll notice how that turns into gray. Signals to be captured. The light pink indicates that it's selected, and the dark pink means it's not. I always select all voltage and all current, particularly because if I get a trigger on one of my phases, whether it be voltage or current, I want to see the waveforms on all my phases, A, B, and C, even if it was only a trigger event on A phase. For the most part, I think those settings work well. So I'm going to click accept here. And that's it. So I can click on save as, and you can give it a name. You can store up to 200 of these configurations that you design. And I'm just going to call this a 1 day 1 day space or wire space wide. And you can get extravagant. You can store about 200 characters in here. I'm just taking a shortcut. So we save the configuration. Now we're going to go back and we're going to actually start a recording, and we can actually set up a time delay if we want. Tell it to start at midnight on Sunday perhaps, or maybe start a few minutes after next power up. It's very variable, so you can choose between 1 and 15 minutes there. But I'm going to choose no delay, starting immediately, and I'm going to erase old sessions. So there we go. We're in the middle of record mode now, so we can come in here, and you can see the flashing R. That's indicating that it's in record mode. If it was a time delay, it'd be flashing T right now. We're going to go to detailed recording channels, and you can scroll through your channels here and see all the ones that are programmed. But I'm just going to set the channels to display, and I'm going to clear all. And I want to look at my 3 voltages and my 3 currents. I don't care about anything else at the moment. So just selecting my 3 voltages, my 3 currents. And click accept. And so there, we can see those. Click back and look under harmonics and phasers. And this is my phasor diagram. And you can scroll between each individual harmonic. This particular unit has interharmonics, so you can view those as well. Remove the fundamental if you like. Change the frequency of the signal. Look at a table of harmonics. And scroll through each individual signal or harmonic. And you can also look at a bar graph of harmonics. I have the fundamental turned off. I can also show direction, and you can scroll through and get out to the 50th on this as well. Click on back. Under waveforms here, you can, oh, I have my fundamental turned off here, so that's not actually the waveform I'm recording. This is. So I turn that on. We're going to look at our peak voltage and determine what that is. We'll click on that. And this is a variable zoom, so if I click a little bit above the graph, it'll zoom in a little bit. If I click way above the graph, you have to be on the zoom function first. A little above the graph, it zooms in a little. Way above the graph, it zooms in a lot. Vice versa, zoom out a little, zoom out a lot. You can also view stored waveforms. And this is a 3D bar graph that indicates that we've had a number of events occur. This one indicates that's a 50%. We had 50% of my voltage retained once, 60%, well, 40% retained once, and both of those happened between 10 and 30 milliseconds. We also had 4 events where we actually had outages between 30 milliseconds and 0.1 millisecond. I can look at my ITIC Sabima curve, and this gives you an indication. Basically, everything to the left of the blue line is most power supplies should be designed to accept those events. Anything outside the blue line is dangerous to supplies. But if you click on one of the red dots, it'll bring you right to the waveform, and you can see the amount of detail here that you have. I'm going to zoom way in right on this spike right here, and you can see as we keep on zooming in what type of detail you can get. We're still in record mode here. We're down here. That's 3 microseconds across that entire screen. So we'll go back there. You can look at a severity, duration, scatter graph. You can look at rankings. This is by time. So if somebody calls you up and says something happened at 8 o'clock last night, click on 8 o'clock and it'll actually show it to you there. Or you can change the list by ranking. And let's see, click up here. Let's see if we can, okay. I was looking at a phase that I had not connected, but here's our number 1 sag, the A phase voltage. You can see what occurred there. So click back and back. And basically that's the configuration and the setup of the unit. We're going to click on stop recording. And one thing that's interesting is if you have a jump drive installed and the recording ends, it will automatically copy it over to the jump drive. However, if you force it to stop, like I just did, it doesn't automatically copy it over. But what you can do is you can go into this Explorer menu and you can click on that particular file and you can click on copy to USB device. You can also review some basic information, but we're just going to click on copy to USB device. And so the information is getting copied over to my jump drive. This is actually faster to get the information than actually connecting up via the USB cable. So it's worth having a jump drive around to do this if need be. So once we get this, basically what it's doing is it's creating an MDM file, which is the binary information, and it's putting it onto the jump drive. It's a compressed file format, and the MDMs are worth keeping as archives. You can rename them, however, it takes up considerably less space than the project database. So we've copied it over. This red line indicates it's been copied. And so that's the operator interface called PMScreens, configuration, and displays. Thank you. Have a good day.